Hi there, this video is about stoich. I want to kind of give you a recap on what stoich is all about. Thinking back to like moles, when we think about moles, what we've really covered so far is this mole map here on this side. This is one type of substance on this side, like all NaCl. Anytime you're talking about the grams of NaCl and the moles and the atoms and the ions and the liters, so that's all about NaCl. If we want to talk about a new substance like this green side over here, that's an entirely new substance. And then we're going to need the mole-to-mole ratio, which is what this middle bridge is all about. There's a bridge with a balanced equation that allows us to go from one substance to the other. And that's all about the balanced equation. So that's kind of where I want to start here. Balanced equation can tell you a lot. Like, let's say you have one of these. This is actually hexane. Actually, that's benzene, sorry. If you have benzene, and then if you want to react benzene, you're going to need two Br2s in order for those to react to create these products on this side. So the balanced equation tells us for every one of these, I need two of these. And in the end, I will get two HBRs and one of these big molecules here. So let's take a look at this bottom phrase. When 4 molecules of C6H6, that's 4 of these, and excess, that's kind of important because then we don't have a limiting reaction situation. We'll get to that later. Are mixed, you will make how many molecules of C6H4? Well, for every one time this reaction goes by, I'll make one of these. If 4 times the reaction goes by, I will make 4 of these. The answer is 4. Let's take a look at another way. I could use the word dozen. Like when you have eggs, you're going to buy a dozen eggs. That means you buy one big carton of eggs. Now, I could use dozen to signify these things too. If I put in one of these, I will get one of these out. If I put in 1 dozen of C6H6, I'll get 1 dozen of these out. If I put in 2 dozen, then I will get 2 dozen out. Now that's not what the question is. Let's take a look at what the question is actually saying. The question is actually saying, if I put in 2 dozen of C6H6, 2 dozen, it will require how many dozen Br2? How many Br2 am I going to need? Well, for every one of these, I need 2 of these. So every 1 dozen will need 2 dozen. For every 2 dozen, we'll need 4 dozen of these. 4 dozen. The balanced equation tells us what kind of ratio we're looking at. Take a moment to think about this one. It's no different than the word dozen. It just includes moles. If you think about moles, moles is really just this same idea of a counting number. 1 mole means 6.022 times 10 to the 23rd. So if I say a mole, you're thinking in your head 6.022 times 10 to the 23rd. If I say a dozen, you're thinking 12. Both cases, we're thinking of a number that's meant behind that word. So here, if I say, if I want to make 8 moles of HBr, I want to have 8 of these. How many moles of Br2 will you need? Well, this is a 2 to 2 ratio. That's another way of saying like a 1 to 1 ratio. So I would say in my head, I will need 8 Br2s to make that happen. Let's do this stoich style. It says, I want to make 8 moles of HBr. How many moles, question mark, moles of Br2 will you need to make 8 moles of HBr? Well, just like any kind of dimensional analysis, I've got moles of HBr on top, so I'll put moles of HBr on bottom. That way they'll cancel. I want to get to moles of Br2, so I'll put that on top. And in order to do that, I know for every 2 moles of this, I will make 2 moles of this. 2, 2. The numbers that go here with the moles when you're doing mole-to-mole ratio are the balanced equations ratios. You could also say it's a 1 to 1 because that's what it is, but I usually just keep it as the coefficients. It makes my life easier. So now we're looking at our mole map here, and we now know this mole-to-mole bridge. The moles of one substance to the moles of another substance. That's what we just did here. Moles of one substance, let's say this is the purple stuff, to moles of another substance, this stuff is the green stuff. So we'll bring it to a more challenging problem, I guess. Really, we've only added one step, the mole-to-mole kind of thing. So it says, how many grams of HBr will you make if you use 25 grams of C6H6? So question mark grams of HBr will you make if you use equals, I'm using color coding my questions, or my numbers, to make it easier, 25.0 grams of C6. And I've chosen these colors because I want to show you that it really doesn't matter which way you go. I mean, the map is the map. It doesn't matter if you start on the right and go to the left, or start on the left and go to the right. So I'm going to multiply this by, now I want to get out of grams of C6H6, so I'm going to put that on the bottom. and I want to go into moles of C6H6. And here's how I know that. In the problem, I'm starting at 25 grams. I'm starting right here. And what I want to do is I want to end over here in grams, my other substance. So this map is going to take me 1, 2, 3 steps. You can see I'm staying on the green side here. I'm going from grams of one substance to moles of that same substance. That's what I've done here. Grams to moles. Grams will cancel, I'm left with moles. And then I'm going to want to go from moles of one substance to the other. That's when I'm going to go from green to purple, or C6H6 to HBr, and then finally do my last gram to gram step. So let's fill in my numbers here. 1 mole of C6H6. Molar mass then of C6H6 is 78.12. That's when I'm going to add up 6 C's and 6 H's and add them all together. Now I'm going to multiply it. I got to get out of moles of C6H6. So I'm going to put that on the bottom. And I want to get into moles of my new substance, because right here I'm doing the second bridge. This is my step number 2. So I'm going to moles of HBr on top. This mole-to-mole ratio is where I'm going to use the coefficients in the balanced equation. So I look at HBr, and there's a 2. And I look at the moles of C6H6, there's a 1. So I put those in there. Kind of running out of space, I'm going to multiply it down here in the bottom. I need to get out of my moles of C6H6 are canceled, but I got to get out of moles of HBr. So put that on the bottom. And I got to get into grams of HBr. That's my last step. This is step number 3 I'm doing. I know for every 1 mole of HBr, according to the periodic table, I have 80.91 will be the grams of HBr. I've got my whole step down, amount of moles into grams, and that's what I want to do this whole time. So I'm just going to multiply these all across and divide, and in the end I'm going to get 51.7857. Sig fig wise, I only want 3 sig figs. All of these are infinite sig figs, so I'm just going to look at my starting one. So I'm going to say 51.8 grams of HBr. My final answer. Hope that helped.